Alright, here it is. Just take a 3-digit by 2-digit number. You multiply each of the digits by their values. You get a bunch of products. You're going to find the sum of these products. I'll move it to the algorithm on the left here, and there is your final product. Alright, so let's slow it down. Now we're seeing a number. It's 312 times 23. There's no difference about how we're going to break this down as we have broken down problems in the past. We take our number that's in standard form, we move it into value form or expanded form. So you have 300 plus 10 plus 2, and then we're going to multiply each of those digits' value by whatever we're multiplying it by's value. So first we're going to multiply it by the 3, which in this case is in the ones place. So you have each one of these is a value times a value. So we'll solve those really quick. 2 times 3 is 6, 3 times 10 is 30, and 300 times 3 is 900. So it's all about getting quick with fact fluency when multiplying numbers with zeros is very important in multiplication, especially when you get into the larger numbers. Now we're going to take the same number, because we have to multiply each one of the digits' values by whatever we're multiplying it by's values. So that 2 is worth 20. So we're going to multiply each of these by 20. And here's where multiplying by zeros again becomes even more important. So that 20 has a 0 in the ones place. We're only multiplying it 2 times 2 tens. So the ones place is going to be a 0. Here we have 2 zeros as placeholders, and then in the next number we have 3 zeros as placeholders. So we're going to go 0, 0, 0, and then we do the fact fluency of 2 times 3. A little practice, the students get this right away. And this is important in when you start understanding the algorithm, is why a 0 becomes a placeholder. So we're going to attack the algorithm just like we did the expanded form. We're going to start with our number, our lowest place values here, and we're going to multiply 312 times the digit of 3, which is in the ones place. So we're going to do 2 times 3 ones, and we get 6. Now we're going to do those 3 ones, and we're going to multiply it by 10. So that 3 is in the tens place. You got to remember that, because that equals 30. And then our next move, we'll take the 3 ones, and we're going to multiply it by 3 hundreds. So 3 hundreds times 3 equals 900. So as of right now, we've just found our first product. We still have to multiply by the number in the tens place. Now every number that we multiply of the 300, the 1 in the tens and the 2 in the ones, they all are being multiplied by 20, which is 2 tens. 2 tens and 0 ones. So we can put a 0 in the ones place and then just multiply everything by 2 tens. Our first problem is going to be 2 tens times 2 ones, and that's going to be 4. Next step is going to be taking 2 tens and multiplying it by 1 10, and we'll get 2 hundreds, because 10 times 10 is going to equal 100. And our final step will be taking 2 tens and multiplying it by 3 hundreds, which is going to give us 6 thousandths. So we're going to find the sum of our two products here. Nice and easy addition. Take your time. This is where mistakes can happen. So 6 plus 0 is going to give you 6. 3 plus 4 is 7. 9 plus 2, we're going to have to carry. The 1 stays. We bring the next one over, and we get 7,176. This is excellent for students to see this. Don't be afraid to come back and show them. See, this was the numbers that we got when we added these sums together as well. And when we find the total sum of these two numbers, just like we did, then we're going to get 7,176 again. And this is going to be our final product. And make sure the students understand that this is the final product. This is not something that students are going to be learning overnight. This takes a lot of practice and a lot of understanding. It also takes a lot of practice for parents and teachers to teach this in a more in-depth manner rather than just carry the 1 or carry the 2. The students really need to know and be able to explain what's going on inside this algorithm. So it's going to take patience from all of us. Good luck.